So we had some open science, and we had a really fun conversation about diversity in science. And now we're here with 3 experts from industry who are going to tell us about their background and their experiences and answer your questions about what it looks like to be a scientist in industry. And they have really heterogeneous backgrounds, actually, and heterogeneous experiences. So hopefully we'll get some really fun questions. And we've got a really healthy audience too, so that's fantastic. I'm really happy to see all of you guys here. So let's do some quick introductions first so we know who we're talking with. So Sophie, do you want to go first since you're going to give your presentation first?
Do I jump right into the presentation, or
well, just
quick
tell
notes?
us a quick background of who you are. Yeah,
no problem. So my name is Sophie Kenny. I'm a PhD in experimental psychology, cognitive psychology, and I work as a staff scientist for a hardware and software company called Vpixx Technologies. Graduated about 3 years ago now.
Great. Okay. And Graeme, you will go second in our lineup. So could you go next?
Yeah, so I'm Graeme Moffat. I am a neuroscientist, did my PhD in cortical physiology. I've been working in industry since just after the end of my PhD in a variety of different roles in neurotechnology and AI companies in Europe and North America.
Fantastic. And then Ferial, briefly introduce yourself, please.
Hi, my name is Ferial, and I'm a research scientist at DeepMind. Yeah, and I tell you more later about my background.
Okay, great. And it's really my pleasure to be here with the 3 of you. And Sophie and Ferial and I also met at a summer school that's very much like this one about 7 years ago now.
7 years now.
And so what's cool here is that we all went through that same summer school together, which was the Cosmos Summer School, organized by Gunnar Blom, Paul Schrader, and Conrad Cording. And we all landed in very different places. And so that's kind of cool to see the heterogeneity of where you can go and the diversity of where you can go. So Sophie, why don't you take it away and give us a little bit about what you do and who you are?
Sounds great. Okay. Everyone sees my screen now?
Yep.
And let's start. Great.
Okay.
So hi, everyone, and thank you for coming here to listen to our career panel on a weekend. I know you've already had a very busy few weeks, and it's just going to continue ramping up, but hopefully you're going to find some interesting discussions in here. So my name is Sophie Kenny, and I'm currently a staff scientist for Vpixx Technologies. I'm really happy to be able to give you a little bit of a glimpse behind the curtain, what I do and how I actually got there. But before I tell you more about that, I also want to tell you a little bit more about myself and my background, because that's actually quite critical to understand what I'm doing and why. So basically, during my undergraduate degree and my master's, I was mostly interested in cognitive psychology and neuroscience as a tool to gain insight into the structures that allow and maybe constrain cognitive processing. Throughout that time, I started developing a really strong background in inferential statistics. I took several advanced classes, and I was also a teacher assistant for a psychometry course, the science behind the construction and validation of psychological tests. By the end of my master's, though, I had worked with lots of different other things, particularly with fMRI, eye tracking, and I had also started to learn coding for the first time. So a lot of people will start maybe even when they're their high school years. For me, I started as a master's student. It was a huge, really turning point event in my life. And it doesn't seem really like a lot to some of you, but relative to my peers and in the context of my field of study, by that point in my academic career, I was already starting to be heavily leaning into quantitative and more objective skills. So by the end of my master's, I really found that I was starting to read more and more papers about visual perception at the interface between the topics I was interested in, cognitive psychology and visual perception. And I started to have a really crucial realization. Basically, I realized that some of the stat skills that I had, even though they were quite good, they were really constraining the type of hypotheses and work that I could do. I discovered some work from a researcher that would later become my PhD supervisor at Queen's University that I found really inspiring. It was all about using Fourier decomposition, PCA, linear discrimination function, and demonstrated really a level of refinement for analysis and interpretation of quantitative and time series data that really appealed to me at the time. So I did basically a full 180, or what felt for me a full 180, going from cognitive psychology to visual perception, and really surrounding myself with a lot of neuroscientists. But through the year, so transferred to Queen's University, I continued just learning more and more techniques, more and more programming languages. And I ended up doing a lot of different things like learning Python, Unity, R, SQL, databases. I learned techniques like motion capture, and I developed experiments for virtual reality environment. So by the time I finished my academic career, I was in a field of study and a field of techniques that was completely different than what I had started with. But something that was quite dear to me, which might sound a little bit strange to some of you, but I really had the intention of teaching undergraduate psychology at a primarily undergrad university. And throughout the time that I was learning and doing all of those different things, I was a teaching assistant for more than 8 courses and a lecturer for 6 more classes. In particular, during my PhD and the year after I graduated, I was an assistant professor at the Royal Canadian Military College of Canada while being a postdoc researcher at the Games Institute at the University of Waterloo. So that's a lot of things to pack in a relatively few numbers of years. And it was extremely interesting and extremely stimulating during that time. But I got to a point where just shortly after finishing my PhD, I was working these different positions that didn't really have much synergy together. And I wanted to continue to be able to code, to do a lot of research methods things, but also to teach. So I actually had the opportunity to take a position as a staff scientist for Vpixx Technologies. And after agreeing with my employers and supervisors, I made the move about 8 months after graduating from my PhD. So what's Vpixx Technologies? It's a privately owned company that specializes in the design and manufacture of research instruments that was founded about 20 years ago now in 2001. So over the years at Vpixx, we developed an entire ecosystem of well-characterized and synchronized hardware for vision science, cognitive psychology, and neuroscience. So we design data recording synchronization hardware, visual displays, precise button box, high-speed eye tracker, and many more things. So, and our products, they're used in a variety of environments, including behavioral labs, MRI and MEG spaces, with humans, non-human primates, some rodents, some insects. The list goes on, it's quite fun. So one of the main things at our company is that we were seeking direct input from vision researchers and neuroscientists and cognitive psychologists to guide the design and evolution of our research instruments. And so this is where I come in as a staff scientist. Within our company, what my role means is that I'm in a front-facing position that interfaces directly with the academic, that interacts directly with the academic communities. So while our engineers and software developers are responsible for designing and implementing new products and features, my role is to talk with those researchers and help shape the directions we're going to take with our products. So for me, I need to understand the current needs of the researchers, identify research trends, opportunities for growth for us. But I rely on the theoretical knowledge, technical skills, and a lot of the shared experiences and values I still have with the academic community to do my role and carry out my responsibilities. A lot of my activities are actually related directly to the things that I care about, and I think other people in academia still care about too. It has to do with the development of workshops, seminar lectures, and most recently also the launch of our new web-based educational platform we call Vocal for Vpixx Online Classroom and Learning, where we try to present to a master's or PhD level important concepts, whether they're about projection geometry, what's gamma calibration of a display, how do you synchronize different devices together, how do you use advanced features to do interesting research designs in vision perception. So yeah, so a lot of it has to do with education. It's using also a lot of the programming and technical skills I've learned over the years. So during the rest of this panel session, it'll be my pleasure to expand on any of the topics that I've mentioned during these last few 8 minutes. And if you find that you don't have time to ask me something, we'll talk a little bit later about how you can get in touch with us. That's it.
Fantastic. Thank you, Sophie. That was really informative, and it really highlights the necessity and importance of this kind of approach to science and this kind of skill set. So thank you for sharing this. And I'll also mention that Vpixx is, I've got a bunch of your stuff in my lab and we use it all the time. that DataPix box that's right behind you. I definitely am very familiar with one of those. Yeah. So we've got, we ran a poll actually, and maybe we can put the results up on the screen right before Graeme goes, about whether you see yourself going into industry or academia after your training. And so if we can put this up on the screen, we'll show you that we've got a pretty healthy showing here of people who are very interested in going into academia. Look at that. So, or into industry, sorry, not academia. And so it's really, this is not an exclusive poll either. You can choose either or, but this is good. This shows that we've got a lot of people here who are interested in what you guys have to say. So that's fantastic. Cool. Okay.
I actually can't see the poll, but I'm interested to know what the numbers are.
I guess I can't show this to everybody. Okay, well, I apologize for that.
You can just tell us what the results are.
I will just tell you there's only 2 options. So I'll just tell you. Industry, the answer is 74% are interested in going into industry, and academia is 53%. So this is not an exclusive. There are some people who voted for both, and that's great because you don't have to know yet. But this is with 120 people who have responded. Here, actually, if I do this, then I can do this, and you guys can see that,
there
right?
We go.
Yeah, there we go. Yeah, so pretty cool. So that gives you an idea of what our audience is looking like. And so, Graeme, I think you'll take it away and tell us about a different role in industry that people can take on.
Yeah. So I'm going to see if I can share my screen with you.
Great.
Open system preferences. Great. Yeah. Zoom. Yeah. Okay. It seems to. Can you guys see my screen?
No.
Okay. Share computer sound. Step 1, whiteboard. Sorry about this.
No, that's okay.
Share.
You getting the screen that pops up that says like?
I'm getting the like you have to share your system preferences. So,
okay. You may have to restart Zoom in order to allow those preferences.
Is that true?
To take. Yeah, maybe. In which case we could go to Ferial, but let's
go to Ferial and I'll come back and do last. Sorry.
Let's see if we can solve this. Yeah.
And I'll rejoin. You guys go ahead.
Okay. All right. Let's do that. So Ferial, go ahead.
Cool. Do you see my screen?
Yes, we do.
Perfect. Great. So I'm Ferial. I'm a research scientist at DeepMind, and my research is focused on reinforcement learning. I guess this is a good time to talk about my research because you all, I guess, started learning about reinforcement learning a couple of days ago. I'm not sure. But yeah, so specifically my research focuses on deep reinforcement learning. And before I get to more details about like sort of my role and what I do, I want to give you some glimpse of my career trajectory as well. So I consider myself an RL agent too, and sort of throughout my studies, I guess changed reward functions that I was optimizing, and sort of went from very different fields and very different career, I guess, options that I was considering, and yeah, changed my path quite often. So this is basically my career path as you can see. And so I can tell you a little bit more about myself. I did my undergrad in computer science, and but I got really excited about sort of cognitive science as well. I was reading a lot of books about the brain and sort of behavior, and got really excited about building intelligent systems. And I was playing a lot of video games, and I was really bothered by how stupid the other agents in the game are, and always wanted to make them better. So I went into Imperial College. I did my master's there in artificial intelligence. And what happened is that my supervisor at the time convinced me that there is no way to solve AI except through neuroscience. And yeah, and I believed him. And I sort of started getting really passionate about neuroscience, and sort of switched basically directions and went to do my PhD in computational neuroscience, or maybe computational cognitive neuroscience. I don't know, like more like studying behavior using computational models and machine learning. It was very interesting, like going from studying artificial agents to human agents, and it's much harder. Nobody told me that when I started. It's quite challenging because you don't have control over all levels of, I guess, analysis that I guess you learn about. You know, like I had to just study the behavior and understand what is going on, while with artificial agents you can actually sort of go down to the representation and actually study and see what is going on, and you can control all of these together at the same time. While in I guess experimental cognitive science, it was really impossible. And my subjects kept coming back to me and say, oh, I know what the goal of the experiment was, and it was completely something else, and they didn't pay attention to what I wanted. And yeah, it was a slightly challenging. And the more I learned about neuroscience, the more I saw there are a lot of unanswered questions. And so I felt like maybe I should go back to machine learning and sort of study and see how maybe by building more intelligent algorithms, we can get more insight into what sort of methods could arise intelligence, like lead to intelligence, and maybe we can sort of contribute back to neuroscience as well. And that's how I sort of, after my PhD, I switched back, and I started getting really excited about reinforcement learning and focus mainly on sort of that problem in the context of you know, artificial agents, robotics, and so forth. And yeah, so I did a postdoc, and I got really excited to sort of try industry. And at the time, there was a professor in Oxford, Shimon Weitzen, who was working on reinforcement learning, and he was starting a startup, and I got really excited to join him. And I worked for around 2 years in his startup, and we were building intelligent cities, or like imagine GTA, but with human-like behavior. And it was quite fun. And then I sort of, startups are really cool and you learn a lot of things, but then I sort of felt like I want to be in a bigger community, more researchers that I can sort of brainstorm with and learn from. So DeepMind was really ideal for what I had in mind. And also it has some neuroscientific, you know, perspectives and aspects. And I really was excited to sort of be again in the field of, you know, both machine learning and neuroscience. So yeah, here I am. And I guess what I exactly do is I'm very passionate about reinforcement learning, and I'm working on making it more efficient and more human-like. This includes hypothesis-driven exploration, or learning across many tasks and being able to generalize to things that you've never seen before, and planning model-based RL, and also learning from humans, how to effectively sort of learn from other agents, which might be humans in the environment. And I'm also really excited and try to help build better sort of reproducible agents, because in DeepRL, you know, as our algorithms got more and more complicated, it's really hard to sort of reproduce someone else's work, and it's actually a problem in the field. So we are actively trying to build these libraries, and we recently put one out called Acme that sort of tries to contribute to reproducibility in this area. I'm also really excited about teaching and contributing to making sure sort of machine learning and advances in science are not kept to a few, you know, companies or academic institutions, and is shared across, you know, the globe. And that's why I really am passionate to build open access tutorials or organize workshops and mentor students that are underprivileged, and sort of try to bring them into the field, because it really matters that we get all perspectives. And it's the only way that we can really build a system that is going to help the society as a whole. Yeah, so also one other thing about AI, so you might want to think how neuroscience can help AI or how they communicate. So I guess there has always been this synergistic relationship between AI and neuroscience, and many of advances in AI or questions that was posed in AI started from neuroscience. And I guess many of you know about the stuff I'm stating here, like neural networks themselves were inspired by the brain, and reinforcement learning, memory, and all things related. And even today, we are still sort of hand in hand with neuroscience, thinking about similar problems and getting inspirations from each other. But I believe we need to strengthen more this relationship, and it's through you guys, like joining machine learning field and sort of bringing your perspective and expertise and help sort of pushing this field forward. And to be more precise about sort of the direction that neuroscience can inform AI and maybe vice versa, is like areas such as representation learning, model-based reinforcement learning, memory, and social cognition are one of the sort of a few of important directions and exploration, for instance, that neuroscience really can help AI at this point. And there was also a paper out by Matt Botvinnik, Jane Wang, and others from DeepMind and UCL, and this actually goes through sort of more details on what I stated here, and I really recommend reading that. Yeah, perfect. And thank you for listening to me. And you can also get in touch with me through my social media accounts and email. And yeah, if you're excited about DeepMind, we also have like information on our website. Great.
Awesome. Thank you, Ferial. That was great. So very different perspective. That's awesome. So now, Graeme, we can.
Okay, let's try this again.
From you. Yeah, let's do it.
Okay. Share. Oh, come on. Come on. Share my screen.
If you want to send us your slides, I can do it from here, and you can just tell me when to advance.
Yeah. Okay. Let's do that.
Sure. Or no, now you should be co-host, maybe. Like maybe you can do that. But I think this might be a system level issue. But go ahead and send your slides. It's a
system level issue. Hold on here.
Go ahead and send your slides, and in the meantime,
I'm going to do that. I'm going to email them to you right now.
Okay. And in the meantime, while we are waiting for our tech challenges to
go ahead with questions.
Yeah, well, we can do a couple questions. Yeah. And I'll also remind people, if you have someone specific that you want to answer the question in the Q&A, type that into the question box, and then we can direct the question to the right person. But we can do a little bit of Q&A while we're getting set up here. There's a big one here at the top. Victoria is asking, hi, everyone. Which benefits does a PhD bring if you want to work in industry after? Does this make sense to do a PhD then? Or should you do something else? So it's like me, I want to answer. Okay, go for it.
So I'm sure Ferial is going to have a very different answer to this. But for me, the fact that a PhD is so long and you have so much flexibility with what you want to do with your time, if you're a really driven person, there is so much stuff that you can learn and that you can see and that you can experiment with that, now I've left the academic world, and I really value the chance that I had to try some things, like even to play around, say, for 2-3 weeks, interactive graphing programs. Like there's, just to say, oh, can I communicate my results more directly? It's a very, very small thing, but now I've just used that for our online web platform. There's so many concepts. So there's just lots of little things. And more specifically, if I talk about my job on a day-to-day basis, there was a benefit because part of my job is also to help with consulting with people so that they can create quotes and get their equipment in their lab, and having a good knowledge of like the academic minutiae and grant writing and timelines and all of those silly things that you don't necessarily see at all during the master's, but you might have seen during your PhD. It really helps feel comfortable and confident going forward. So that's more of an intangible, but there are practical aspects to it. That's it.
Okay, can you guys hear me? I'm back in.
Yeah.
Yeah. Okay, Megan, great. I'm on my iPad now, so let's see what we can do here.
I was not, I was muted.
Success?
Sorry. So we'll
Okay.
come back to that question
Yeah.
afterwards. And we'll finish that up. Great. Okay, I'm glad that we're getting the screen sharing working. This is great.
Yep, we are going to. Okay, so you guys can see this, right? The slides? Hello? Shoot.
Yes, we could.
Yes.
Oh,
good?
actually, no, sorry. It says you
Not
are
anymore.
Now it just says
Okay.
share screen, but
I'm
you could see the
I'm-
slides.
You could see the slides.
Yes.
Okay, here we go.
Yay,
All right.
slides.
Yeah,
Okay.
so sorry about that delay. So I saw in the Q&A a couple of questions about, how you make the transition to as a neuroscientist or a neuroscience grad student into a career in the private sector. So that I'm really glad to see those questions, because that's something I'm sort of passionate about. My talk is going to be a little bit different than our previous presenters, in the sense that I'm going to talk a little bit about more about like how to think about a career and how to make the transition, and how to think about how to learn how to get into the private sector and industry. So my background is specifically more related to neurotechnology than it is to AI and comp neuro, although I have done a little bit of each. So my career trajectory so far is I started out during my PhD working on an industry sponsored project with a company called Neuralec, doing cochlear implant manufacturing and research, and new applications for cochlear implants. So sort of the original BCI, brain-computer interface, and then moved into open science as the managing editor of Frontiers in Neuroscience directly out of my PhD. I then, after about 4 years at Frontiers in Neuroscience, joined Sciencescape, which became Chan Zuckerberg Meta, which is an open science discovery platform, and went on from there back into the brain-computer interface world through Interaxon and Muse. So this was a sort of a significant transition back into industry on the away from the information and AI side, back into the BCI hardware side. And recently, in the last year, a friend and I, a colleague from my previous job, co-founded a new company, System2 Neurotechnology. And we're in stealth mode. We're working in the brain-computer interface space. Along that way, I've had academic affiliations and partnerships with universities. So I still continue to work with academic scientists a lot. And in the neurotech space, there's a lot going on. So you can really build a career in neurotechnology now in a way that you couldn't 5 years ago. If you have a neuroscience or an engineering, electrical engineering, biomedical engineering background, you can really do a lot more now than you could even a few years ago. There's so much more going on. There are so many more companies starting up, and it's just getting bigger and bigger. And a big part of this is Elon Musk and Facebook and Microsoft getting into the space in significant ways. So then it becomes, the question is what's going on out there beyond the big names. There are companies not just in the BCI space, but in the medical and diagnostic imaging space. There are consumer and clinical and established and even companies like Vpixx that sell principally to research labs. That's another big industry that you can move into if you have a background in neuroscience or engineering. And you can work in so many different fields now and so many different kinds of companies that even without leaving neuroscience or without leaving neurotechnology, there are tremendous opportunities. So then, the question is, what if you're working in an organization, whether it's a research-based, principally research-based, or BCI or neurotech organization, or another one, what value is it that you as a neuroscientist bring to the organization? And there are a number of them, but the biggest one is, initially as you join the organization, you might not know your job that well. But you bring credibility and rigor, and you have up-to-date knowledge that nobody necessarily in the organization has of the latest and greatest technologies and techniques in neuroscience. You have excellent communication and reporting skills if you've gone through multiple iterations of university, whether it's undergrad and graduate school and then postdoc, or even just undergrad. You've learned how to communicate, and you can analyze and synthesize complex information. The reason I'm emphasizing this stuff is that I think there are far too many graduate students and scientists out there who really sell themselves short. They really don't know, or they really don't fully understand all of the things that they've learned how to do when they're trying to make a transition into a new job or a new industry. So you're not just bringing your specialty knowledge like deep learning or AI or neurotech or neuroscience. You're bringing all kinds of skills. and you can help a company to hire you. So to make that transition into a company, there are a number of things you can do that make it much easier, especially now, given that governments are spending so much money to try and help students find jobs. So there are lots and lots of governments that offer partner funding for collaborations between academia and industry. And there are funded programs for students and postdocs while they're in their grad school or even undergrad or postdoc to do partnered projects with industry. And those are sponsored often by matching funding from government and industry. So if you're going to try and make this transition, there are some basic things you want to do. You can develop your skills, which is what you're doing here. Showing off what you can do is very important. So sharing parts of your GitHub or Bitbucket repo shows prospective employers what you can do. I've hired a lot of neuroscientists and engineers in the past 10 years. And I've always, the ones that are always the most appealing and the ones who get past the first few stages of interviewing are the ones who show their work, whether it's publicly or share it with you privately. If you want to get a job, you can bug people. You don't have to ask once or send in your resume and stop asking. You can bug people extensively until they call you back or until they tell you to go away forever. And if you think about the kinds of jobs that you can potentially get into in the private sector, it doesn't have to be the perfect fit. You don't have to look and look and look to find the perfect job. You can join a company that you want to work for and find interesting, and very quickly grow or transition the role into one that's more suited to your skills and what you want. Okay, now you don't just have to stick with the research and development side. So as you learn and as you grow into a more senior role in the private sector, and this happens much faster than it does in the academy, you're going to learn about business. You're going to learn about operations in business. You're going to learn about finance. You're going to learn about marketing and sales and a whole bunch of other things. And you'll just pick this up along the way, but you can hack your way into it pretty easily. So how do you hack your way to business knowledge? Okay, well, one way is to just read some good books. These are 3 books that I strongly recommend to anyone who's interested in moving into the private sector on how to manage, how to learn how to do effective management, and some of the techniques and strategies for doing this, learning this not through trial and error and long-term experience, but setting up systems to be an effective manager if you're a junior person or if you're just starting out. You can take courses at your university. You can take courses on policy development, which help in both business and the public sector, and even in universities. You can sneak into MBA courses and you can learn business shorthand. You can find mentors in business. There are lots more business people, lots more people working in the private sector than there are in universities. So there are lots of people out there you can ask for help. One mistake I think a lot of people make when they think about a scientist anyway, and grad students, is they look at organizations and they see a hierarchy like this. So they see what's called an organizational chart. And there's this big hierarchy, and you think of yourself coming in at the bottom and going, oh man, I have to pay my dues for so long. If this is like the academy, this is going to take me forever. But that's fundamentally the wrong approach to thinking about organizations and careers in the private sector. The way you want to think about it is path dependency for your career. So you have lots of options, and you're going to change, if you go into the private sector or into industry, you're going to change companies more than you change universities in the academy. You're going to change jobs very fast. So you might end up with 2 or 3 different roles in the first 5 years, or promotions or transitions of your career, and that will continue on. So you're going to work in a lot of different things over the course of your career. I've been in the private sector. I finished my PhD in 2010, and I've worked in 5 different private sector organizations since then. Some of them for as little as 2 years, and some for 4. So one thing to think about when you're trying to think about how you would make a career or how you would transition into the private sector is that you don't have to pay your dues like in academia. It's not this many years to do this. Advancement can happen very, very fast. You'll change companies more than once. So if you look at it at the tech space in the United States, a tech worker typically spends at one company on average 2 years. That's the average. And an executive about 4.5 years. So you can also think about this in terms of being a specialist or a generalist. So if you're an R&D, you might be very motivated to become an R&D specialist in your area, and you can become indispensable to an organization that way. If you want to become a manager and work with a broad range of different parts of an organization and learn different skills and get into business. And business can be pretty exciting. It's actually kind of if you think about it as a scientist, a lot of us tend to think business is kind of boring. But once you get into it and you start to advance a little bit, it gets pretty exciting. There's a lot of risk. There's a lot of very fast moving. There's a lot of reward. So if you become a manager, you can generalize and you can advance in the hierarchy of the organization. And one of the most important things when I've counseled and mentored people, and things that I've learned myself, are that talent and hard work and good ideas go far, but you have to communicate. Communication skills are absolutely essential. So you have to tell people what you're doing, you have to tell them where you're succeeding, and you have to tell them where you're failing. It's like having a meeting with your advisor, every week, and being totally honest about where you're succeeding and where you're failing, because it's much more teamwork within the private sector. And you have to interact with many more people, and you have to communicate with people who have much more different backgrounds than you. You have to send a lot of updates, and you have to, and this is especially tricky. I had trouble with this in my transition is, rather than sort of pushing ahead your own ideas on your own project, you have to, in order to move your ideas forward and move your projects forward within a big organization, you have to socialize those ideas with teammates and win support before you pitch them to senior management, or before you try to get them on the agenda for the organization. So the most important thing to remember is that if you're making a transition to the private sector, you're a scientist or an engineer, and you can figure out business. You have all of the tools to systematize this and figure it out. So don't get discouraged if you try to make this transition. There are lots of good resources out there, and it's not going to be easy, but it will be rewarding and interesting. So with that, I'll hand things back, and I think that's probably most of my slides.
Great, thank you, Graeme. And as I said in the chat, I wish I'd seen this a few months ago when we started building NeuroMatch Academy. I think we would have learned a lot from this.
Yeah, that's sort of a talk I gave at one of the brain hacks in Toronto. And then Gunnar asked me so Gunnar and I, and this is another thing you don't know about working in the private sector, is you don't have to leave all of the academic science behind. So Gunnar and I know each other because we sit on the Natural Sciences Granting Council in Canada, and we go up to Ottawa every February, and we hang out together and we do some grant reviews. And so he asked me for some slides on this to use for his students, and so these are some of the slides that on that. So this stuff I've thought about for a while, and I think it's not communicated enough to grad students just how it is to think that you can think about all of your skills. There are so many things that grad students don't know that they know, and postdocs don't know that they know. You tend to think it's really, really hard to make that transition to industry, and it can be. It's daunting. But rather than thinking about making a leap into like the low level of an organization, you got to look at it sort of as this myriad number of opportunities and all these skills that you already have that can help you along the way.
That's a perfect lead in from the question that we had that we were answering while we switched over to you, which is, what's the point of doing a PhD if I want to go into industry, or what do I get out of the PhD if I want to go into industry? And I think that you've answered that very nicely, that there's and that Sophie also answered very nicely, that there are a lot of these skills that are extremely transferable, and you don't necessarily see that because it's not explicitly, taught to you in that way.
If I can just add something on what Graeme just presented really clearly to us. So I don't have the perspective he has for a much longer career after outside of academia, but what he described matches point per point what I've experienced. It's moving there in my own specific example. So I'd say that's pretty accurate for me.
And Ferial, I wanted to give you a chance to weigh in on that question before we move on to the rest of the fantastic questions that we have.
Great. So the question was about like, what do you learn in your PhD? So
yeah, the skills that are transferable from the PhD.
Yeah. So I think now when we're talking about our career trajectory, it looks like everything was smooth and sort of we were going exactly where we planned to go. While I was doing my PhD, I suffered tremendously and I was really stressed and I didn't know where I'm going, didn't know why did I come here. And I guess I was doubting a lot, what did I really learn? But I would say I fully agree that many of these skills are transferable. And when we are in the PhD, we don't know that we are learning them, like project management, communication. When we give presentation as conferences, right? We are learning how to articulate our ideas that might be very complex, and you need that when you're in a company and you want to communicate with your manager or other colleagues, and sort of there's a lot of overlap, although it might be very different, the context. But yeah, I absolutely think yeah, PhD is a great way to prepare yourself for a career in industry, but you need to keep that in mind that there are alternatives as well. You don't really need a PhD to do research in industry. So for instance, even at DeepMind, we have research engineer positions that are for master's students, right? Or undergrads. I mean, you could get into industry and do interesting jobs without actually having the PhD. And maybe you try for a few years, learn a lot of skills that maybe even helps you do a PhD afterwards, right? Proper coding practices, or like group project, how to work in teams.
Yeah, that's a really important point that I'd like to just sort of riff on a little bit. Is you don't have to go straight into a PhD out of undergrad or a master's. In fact, most of the people I know who've gone on beyond their PhD to do sort of really interesting things have had these interruptions in their career where they're not just going straight down the academic track to the end and then making the transition. Often you get a lot more out of a PhD if you spend a year or two working in industry in something that you're interested in, because you have a completely different perspective on the applicability of research and the kind of work that you're doing inside the academy. It's very easy, I think, for anyone who's working in a highly specialized technical field to sort of get lost in it and lose perspective. And working outside of the academy really helps you to keep that perspective throughout your PhD.
Fantastic. Awesome. Thank you. So I want to push us forward because we have so many great questions. And I'll preface this by saying we're not going to get to all of them, but I want to continue the conversation on NeuroStars, and we can maybe set up a Slack channel or something for some of the TAs, and the students can interact with NeuroStars and other stuff. So if we don't get to your question, it's not because it wasn't a good question. It just means we ran out of time. So the next question actually is a set of questions that I think kind of go together, that are largely grouped around the idea that if you're coming from a less technical background, but you're really interested in doing this, what is the best way to gain that technical background so that you can target these types of careers? And if you do that, there's a question specifically to Ferial, but I think it's appropriate for all three of you, which is, how much of a hardcore computer science or technical background does a junior level person need in order to be successful in these various types of industry careers? So I think in a nutshell, how much technical background do you need? How do you get it? What's the best way to do that for these different goals? So does someone want to go first for that one?
I can go first, mostly because I have the less to say. I am not a person with very strong computational skills. I know how to program, implement experiments, and work with hardware. But for me, the benefits of my background is mostly theoretical. But other employees within the company, so not staff scientists, but software engineer, hardware engineer, for them, these type of things do come into play when they're looking for implementing different types of algorithms and actually make the devices work. But that's pretty much all I have to say.
Graeme,
I can add a little bit, I think. One of the most important skills in especially large organizations, large tech organizations, is the go-between and the communication between the technical, like the coders and developers and the technical staff and engineers, and business and sales and product teams. So there's an especially difficult challenge there that people are particularly suited to if they're not necessarily the strongest technical background or scientific technical background, but if they understand the concepts and they're good at communicating. Being that kind of go-between between the technical and non-technical sides, or the technical and the business sides, is an especially important role. And there are lots of those kinds of roles. Like, those are typically the kinds of people who become product managers in tech companies. They understand technical stuff. They don't necessarily have the best coding skills. That's the developers or the data scientists. but they have a big picture way of looking at things, and they can communicate effectively on both sides. So the other thing is, one of the hardest transitions that technical people make, especially if they want to keep going and eventually manage teams, is to become more effective in an organization, in any organization, whether it's academia or the government or private sector. You sort of have to delegate. You have to build a team, and you have to learn how to help organize and manage people. And that's about motivating people, and it's about communicating. And the hardest thing about that is, for technical people, letting go of the technical work. You can still do some of it, but eventually someday, when you become a manager or a team leader, you have your teammates coming up to you and describing something, and you sort of nod your head, and you have this realization. You go, this person knows way more than I do about the thing that I'm supposed to know about, that I was the expert in, and now they're the expert, and I have to look bigger picture and help them do what they're doing. So it's kind of it's devastating to your ego to realize that you've got people on your team who know your technical stuff better than you do. But it's an inevitable transition for everyone who becomes a team leader or an organizational leader. So it's the technical skills are something you can stick with, or you can move into a leadership role, and it becomes much less important to actually have totally up to date. I don't know all of the Python libraries and toolkits that I should, but my teammates do, and I know where to look, and I know how to talk to them about it. So that's sort of an important. I think the technical part is sort of there. The technical requirement is sort of oversold a little bit in industry. You have to know stuff, but you can learn and keep going, and then you can transition out of the technical side as well.
And maybe though, if you apply with a position that does suit your skills at the moment, right? Like I would have never applied for a computational neuroscience position or an engineering position within the company, and vice versa. They wouldn't have applied to my positions. You can move as you learn, but you do have to be useful when you start.
Yeah, absolutely.
Ferial?
One tiny thing I want to add is, so it was about I'm going back to the question because I think it diverged a bit. So about how much hardcore computer science knowledge you need to know. So I would say it's not really hardcore computer science knowledge that you need. It's more like, let's say in neuroscience, we often use MATLAB a lot, right? And I would say stay away and switch to Python. You really need to know sort of programming languages that is commonly used. And Python is one of the most general used programming languages for a scientist in industry or academia. And I really recommend go for open source code, put your code out there. Just if anything, just try to put it on GitHub or on your website, because, I often get a lot of CVs and I can't really assess what right? If I can't see examples of it, or I can't see that you've built stuff. And I think it doesn't have to be big. It just has to be some small thing that you've done, and it's really impactful, right? I think these things. And also in industry, there is a lot of opportunity for learning. Sometimes people don't realize that, but in many companies, they provide a lot of teaching resources that help you build your skills in the job, right? So don't worry too much about you have to be perfect before applying to these jobs, right? As long as you know and you can relate your skills to the requirements of the job to some extent, that's fine. You don't have to tick all the boxes that are in the job description. It's a mistake that many people may make. So yeah, that's it.
Awesome, thank you. Great, so let's move on then to the next question. So there's actually another cluster of questions that all seem to kind of go together, which is a very concrete set of questions. How do I find jobs? How do I find internships? Where do I look? And so I think that this is a very practical question that warrants a little bit of attention here. So what do you guys think? Any suggestions here of where to look?
Okay, one of them, go to every relevant forums or mailing lists in your area. For me, that's how I learned about the position that I am in at right now. And it was one of the few places where it was posted. Be proactive. If you are interested in a particular company, don't be afraid to visit exhibitor booths at conference. Sometimes you'll be surprised with how high ranking people that are at the company are there. And when you talk with people, be eagerness, present yourself well. Very often there are actually the presidents, vice presidents, managers that are present, even if there's no advertised position. That can be a great way to learn a little bit more. Not a lot of people do that. So you would definitely pop out. That's one option for us.
Yeah, I'd say the same thing. I'd echo that. It's, you know, part of it is, and a lot of people hate this idea of networking, but, you know, it doesn't have to be some sort of horrible kind of glad-handing self-promotion. I've been offered jobs. I was offered a job straight out of grad school just because I went up to a bunch of booths at the Society for Neuroscience meeting, exhibitor booths, and asked a bunch of questions and got interested in what they were doing. And then people follow up with you if you seem enthusiastic and knowledgeable and interested in doing things. The other thing is in neurotechnology and BCI stuff, there's a very good group organized by grad students in Montreal and San Francisco and around the world called NeuroTechX, which is sort of BCI enthusiasts and neurotechnology enthusiasts. And we have a Slack channel and website, neurotechx.com, and there are job boards there. Another one is if you're a little bit less on the technical side, you know, if you're less hardcore conventional until neuroscience and psychology research, user experience research and user experience design and human computer interaction design and research are very, very big and rapidly growing and rapidly expanding fields. There are tons and tons of jobs in this field for people who have, you know, who have some experience in human experimentation and experiment design. And you can find these on recruiter websites and on company websites. So there are lots of things that you can do, whether you have, and I think it's computational stuff. It's pretty easy to find a job as a data scientist because they're all over the place. But if you're less technical, you can still find great jobs in neurotech and in technology through some of the more experimental psychology kinds of disciplines.
Yeah, I agree with everything that was mentioned. And one thing I can add is like your friends that you're at the summer school with now, right? Like they're all going to go in different paths, and they could be, you know, you might be interested in a career that they're going to be choosing in the future, or the company that they're going to build, right? So keep in touch and definitely keep in contact with people that you meet in these summer schools. I have like amazing friends from then and learned so much from them, like Megan and others. And I really, really recommend like keeping in touch with your colleagues and peers, as well as sort of reaching out to maybe other people that you see in companies that you care about, and they can recommend you other positions as well, right? Even if their company is not hiring or something. But yeah, networking is the best.
Actually, about that, Ferial, that's a really good point. I know for me, I certainly made the quote unquote mistake of being way too focused on my work and putting just the work in front. So doing some conferences and summer school, stuff like that, I was very much like, I go in, I go out, I study, I go in, I go out, studies, and sometimes not taking all of the opportunities. So some of them, it's funny, you know, you get back in contact with people, you know them better later on. But even if you stay in academia, especially even if you stay in academia, it's so important to get to know your peer as kind of friends and not just as co-workers. Yeah.
So the take-home message is bother people and build a network, kind of. And I'll point out there are 141 attendees in this panel, and about 75% of them said that they were interested in going into career and industry. And if that's representative of the folks at Neuromatch Academy, even in the slightest, then there's a large community of people who are interested in this. And so share resources, share experiences. Okay, so there's another group, a cluster of questions that I'd like to get to before we wrap up. We can run over if you guys want to, or we can kind of wrap it up. But there is one I think that's really important, is this cluster of questions that's about the kind of cultural differences between academia and industry. And one of the versions of this is, do you feel a big difference in intellectual freedom shifting from academia and industry? Another version of this is, how attractive would it be to go back to academia after being in industry? And so I think maybe talking a little bit about the cultural differences and the pros and cons of each type of career path might be something to talk about here. So would you guys want to jump in on that, Guy? No?
You guys go ahead.
Okay.
Okay, I can say a few words. Partly for me, part of the culture shift was one of the reasons that attracted me to change to industry. One of it is just I really like, I've discovered that I really like working with people in groups of different backgrounds, quick iterations, quick projects, doing things that I can work on and know that they're probably going to exist for a few years after I'm done on the project. I will not lie and say that I don't miss doing a lot of research, but I am very blessed that in my position, part of my role is to keep up with research. So, and tools and new methods so I can continue to read, and I'm encouraged to continue to read, to take classes on the side, can take up all of my time like it would have in the PhD or postdoc. But it is seen as part of my sort of professional development. And networking colleagues, friends that want to help you continue running pet projects on the side. That's something I've been able to publish one experiment in particular that was directly linked to my work and was just an experiment I wanted to do and try. But sometimes, yeah, you do miss it. But there's lots of other positive things about it too.
Yeah, I agree. I mean, I guess while I was doing my PhD, I really didn't think I want to teach or like be a teacher, like, you know, or like have a class. And that was one of the reasons sort of I wanted to get out of academia. Maybe because I didn't have good experiences TAing for courses. I really don't know. But now that I'm in the industry, I'm really passionate about teaching somehow, and I really love it. And I feel like, you know, actually maybe like academia would be nice, but I'm lucky that in my job I get to teach, and I get to I can go to summer school. I can participate in online courses that DeepMind provides and stuff like that. So I'm very lucky that I can have that. But I can see myself, if I was in a company that wouldn't allow me to teach, maybe I would consider going back. But I guess it highly depends on the company that you're in. Some are heavily research based. For me, I feel exactly the way that I was feeling in academia in terms of the, you know, the research I'm doing, the kind of research. Maybe I have just more support and more pool of people to collaborate with, which is really nice, you know, for me, as I had this characteristic that I like to do teamwork rather than, you know, isolated research. So I guess depending on your, your company and yourself, you might want to go back sometimes. And yeah.
Yeah, from my part, I found the same thing, actually. A lot of the things that I found particularly stifling and annoying about the academy by the end of my time there were, once I was out in industry, were no longer annoying. Like my friends from grad school who were still in the academy would invite me to come and give guest lectures in their class. And it was a lot more enjoyable than when you had to do it and you were on a schedule and you had to do all of this kind of grinding administrative and prep work. It feels more fun to do academic kinds of things now. The big difference in terms of like research and to the question of intellectual freedom, I don't think you have any less intellectual freedom in the private sector, but you just don't have as much time to go down blind alleys, and your timeline to turning a project around into something practical is not it's not like 5 years. Like there are very few companies that can afford to spend 5 years on a project. So you really have to turn your work into something practical within kind of 18 months, and you have to show progress along the way. You can't go down as many blind alleys and spend your time on intellectual and esoteric pursuits as you can in the academy, which is, that's for some people and not for others. I think it's less on the question of going back to the academy. I think it's much less difficult now, and becoming less difficult still, to go back to the academy from the private sector. In engineering, it's never really been a challenge. Like lots of people with PhDs in engineering go into the private sector and then go back to university, and in chemistry as well. So in scientific disciplines like chemistry, 80% of PhD grads go on to the chemical or pharmaceutical industry, and they often go back to the academy at some point in their careers. This is It's really only in biotech and life science and neuroscience that it's kind of a new thing to have people transition back from the private sector into the academy. And it's not that common yet, but it will become more common. And I think it'll become especially more common to have done, a couple of years of a postdoc in industry and then do a postdoc in the academy and then continue along your academic career track, or to do 5 years in industry after your undergrad and then go into a PhD. So these things are all opportunities. There are a lot more ways of finding a career track and a career path than there were in the past.
Awesome, thank you. And there were a couple other questions that we actually hit along this conversation, which are, once you leave, can you go back, and how do you integrate the two? And I think it's what I'm hearing from you guys is that it's really important to think to highlight that this isn't a one-way door necessarily. That there shouldn't be this divide, and that some of the things that we who stick around in academia and stay there, kind of these rumors and these negative things that get propagated, these questions that we're getting in the Q&A that are about, there's less intellectual freedom, and these are rumors, and it's not necessarily true, but they are prominent rumors, and so you shouldn't feel bad to have run into them and to believe them or anything, because there's things that I hear all the time too, and that for a long time I also believed, and I think that it's really important to highlight that they're not necessarily true, and that there shouldn't be this this hierarchy. Yeah.
The misconceptions go both ways too. If you spend enough time outside of the university and you get used to the private sector, what you find is that a lot of people who haven't spent a lot of time in the academy think that most people in the academy are kind of wasting their time. And they're pursuing very esoteric things that have no practical application, and they're going down dead ends, and there's stifling limit of conformity in some respects in the academy, and you have to say no, it's not quite so stifling. But then there are also there's been a lot of discussion about mentorship and bullying and the problems in the academy with very problematic relationships between advisors and graduate students and those kinds of things, and it's quite heartening to note that the kinds of behaviors that you hear about, that the worst behaviors in the academy that go on for years and then get caught and then there's a big inquiry, those people get fired in the private sector. You can't be like that. They get fired immediately. So the people in the private sector are generally more kind of collegial and less siloed and less protective of their little niche, because you can't be in a company. You have to get along and work with other people to a much greater extent than sort of staying in your narrow lane as you do in the academy.
Awesome. Well, this has been an extremely informative discussion for me. And I hope also for all of the students and teaching assistants and observer and interactive students who are here with us. We have so many open questions still and so much going on in the chat. And I think that we could be here forever if we wanted to keep going. But in the interest of spending a little bit less time in front of screens, because we've been doing that a lot recently in Neuromatch Academy, I think that we should probably wrap up here. But before we do, I want to give each of you the opportunity to leave us with some parting words of wisdom about your experiences or the exchange between academia and industry, or anything else that you think is important for our students, our teaching assistants, everybody here in the audience to remember about this panel. So I'll let you guys self-organize unless I need to call on people, but who wants to go first?
I always volunteer.
Okay.
So my words of wisdoms are a little bit something that I haven't touched too much in this presentation, but don't let the fact that you've done check a master's, check a PhD, check a postdoc define you and your abilities. Really get to know yourselves really well while you're in the process of doing this, and know what you like and what makes your strengths. Because when it comes the time to find a job, you're not going to try to look for a title name or a company name and say, I want to be here and I have this, 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 and this. You have to be a really strong advocate for yourself and be very flexible and very driven, the way that you think that your skills and your background are going to be a good fit for a certain company and their own objectives. And there's much more flexibility and opportunities out there than you can imagine. But it starts with you knowing yourselves, because just reading at your CV, that's not telling us how you in particular could be the person we want to hire at this specific moment in time.
Great. That's great. Who wants to go next?
I guess the one thing I hope people will take away from this is that the world can look a certain way and industry can look a certain way from inside the university, but it's so much bigger. The world of like private sector businesses are so much bigger, and there are so many more paths than there are in the academy. It's so much less regimented, and things can move at radically different paces, and you can try something out and you can switch direction and you can switch companies and you can switch roles. And your career development path can go in many, many, many different ways outside of academic science. So you can become a business specialist as a scientist. There are bank presidents in Canada who have PhDs in physics, and it's they have problem solving abilities and they learn things and they go in a completely different direction than R&D. So there's so many different paths that you don't see until you really get out of the academy. So don't get discouraged if you look at something and it looks difficult to get into, because once you make that leap, there are lots and lots of opportunities.
Fantastic. And Ferial.
Great. Yeah, I think I would say what I said yesterday in the RL panel, that you need to be happy and you should really use happiness as your reward function, because seriously, like you can really fail in something you don't like and just you picked it because to be successful and because everybody around you was doing it, and that's really hurtful. And you should pick a career, a topic, I don't know, whatever that makes you happy, and that way you can be successful. And that's I really, really believe in that, and that happened for me as well. And also I would say, when you pick a career, think about also the implications of the job that you're picking. Sometimes we forget that our actions have consequences in the whole world. And I would say as scientists, we have a lot of knowledge, we have a lot of skills that we can use to help the world a better place, especially like using machine learning, using neuroscience, using all the techniques that we are learning. I think now there's a lot of opportunity in startups, in many companies to do good and to make the world a better place. And I really recommend thinking about those career paths as well. These are in healthcare, in social justice, in education, even help improve education, or many other directions. But yeah, and keep in touch. And sorry we didn't answer your questions. We are always, I guess I'm on Twitter, and I'm also accessible using my email and website. And yeah, and I'm happy to help and advise, or I don't know, answer any questions that are left unanswered. Thank you.
That's a really lovely sentiment to end with. Thank you, Ferial. So please help me thank our speakers. You can type in the chat or whatever, but thank you very much, Sophie and Graeme and Ferial, for sharing so much of yourselves and of your insight with us, and stay in touch. And if we didn't get to your question, again, it's not because it was not a good question. It's just we can't be here all day, unfortunately. So keep the conversation going.
Yep.
Lots of good questions that we just didn't get to. So
thank you for the opportunity. It was great to talk with everybody.
Yeah, it really was. Okay. So thanks again for being here, the three of you. We really appreciate your time, and we'll see you next time. Bye.
See ya.